Hey everyone. So this is Glaciers Lab 2 or Lab 10 overall. And luckily it's a pretty easy one. We're just using this program and the directions I think are pretty good for it. So you just kind of follow the directions step by step and um, you get through it pretty easily. So there's really not a presentation I can give for it, but I'll show you some of the tools just so you have an idea. So this is what the program looks like when you open it. I'm just gonna reset it. So what we notice, so here's our glacier. And then this top view shows if it's an even taller glacier. So let me make it really big. So if I do that, I just increase the snowfall and drop the temperature. That's going to increase the glacier, and we see it kind of advancing here. So we can use the arrows and just see along where it is. And this little bear is showing which snippet we're looking at. If we don't want to wait for it, because that takes time, we can pick this button, set glacier to steady state, and it will just fill it all in. We notice in the bottom left corner, we have years going on. So it's passing over large chunks of time. So we also notice on the surface here, so it's white on this part. Then around the middle of the glacier, it switches to gray. So that represents the ELA line. And then let's see, let me come on. There's a pretty good picture of this in the lab itself. Yeah, so this white is the accumulation area and this gray is the ablation area. And so the first part of the lab is measuring glacier thickness, which we can do with this tool. And then let me reset this, do it over a smaller area. So we can drop this tool down and it will just give thicknesses throughout. Make sure to set it to metric as well. So it's gonna, every time you reset it, it's gonna be on English units. We want it in metric. And you can measure different parts throughout the glacier, dropping as many of these tools as you want. It'll spit out the exact meter thickness. That's how you use that. Let's see, another helpful tool, if we go into advanced, which we were in, awesome. You can turn on coordinates, which just turns on the X and Y axis for actual distance. So it starts at 0 meters and just goes on down. And we can also use this little GPS tool and drop that anywhere we want, and it will give a distance and elevation as well. So that's pretty helpful. You see, I have the lab open next to me just so I can yep, and then we can play with these. So dropping the temperature, we'd expect, yeah, the glacier to probably get to advance. Increasing the average snowfall, we'd expect it to also advance. If we take all the snow away, it would dry up. Same thing if we even if we make it cold, if there's no snow, it won't build up. You can just play around with that. So next part is asking about mass balance. So I'm going to reset again. And I'll make this glacier a little longer. So we can use this green box for mass balance and just drop it wherever you want to take your reading, and it will spit out the mass balance numbers for accumulation, ablation, and the glacial budget. And you can drop multiple ones. I think it wants one on the ELA line, but these units are not correct. You're going to want to change these around to make it the longest possible glacier that you can. But the one thing that should be hopefully the same In a perfect system, is your glacial budget at the ELA should be 0, since they would like kind of balance out. But it probably won't be perfect. Like this one's pretty close, but so that's how to use the mass balance tool. Then the next part is asking about velocity. So there's no specific like tool for velocity on this, but if we think about what velocity is distance over time. So a helpful tool for this, I'd recommend I'd recommend turning on the coordinates for it, and then this little arrow tool kind of helps. This flag tool, and if we drop it, it'll move. So what might help is if you like reset again. So maybe you want to pick like a starting spot and be like maybe at 1,000 meters or something like that. Drop a flag, starts at 2 years, and let it go for a certain period of time. And then maybe I'll pause it at like 2,000 and just see how many years passed, and maybe you can get a velocity that way. And see, I have this, right? Just to try to help you. So velocity is distance over time, and we're going to want it in meters per years. And just make sure it's meters, because every time you reset it, it's going to switch back to English units. And we want it in meters, so just make sure to change it to metric. And so question 9 kind of just asks you to explain a process to find velocity. So I'm more just looking for an explanation, and there's a few different ways you could do this. And then question 10 is asking to try out the method that you explained. And then 11 is asking about how these flags get buried. So what it means by that, if we drop a flag at the top here and let it play. So on this line, this is the surface, but if you see we give it enough time, it kind of looks like it's sinking into the snow here. It's not really sinking, it's more just there's more snowfall on top. Since this is the accumulation snow, we have area, we have snow piling on, and then it passes the ELA, and snow stops falling on top. So we're starting to more melt the surface until it kind of reaches the end here, and it gets on the surface again, and then just falls over. And then the next part is looking at the drill tool. So let me let it play. So it just puts a line as if we drilled a hole, and then we can see that the speeds are different depending on where we are in this ice. So at the top on the surface is going to be a different speed than on the bottom, and it works the same wherever you are. One problem I was having earlier is if this glacier is really tall, the drill will like sit up here and you can't use it, but that's all right because they kind of do the same wherever you are. They kind of have that same pattern, so you can still answer the question. And the last part is asking about moraines. So let me reset one more time. If we notice there's some little black dots throughout this glacier, let me speed it up. These are like rocks and sediments that build up in the glacier, and then they get carried throughout and they get dropped on the front here. So this line here is representing a moraine. And if we were to like drop the glacier back, right? See, it leaves it there. So that's what that means by moraine. And the lab offers some nice pictures for that. So yeah, so the front of the glacier is a moraine. You would retreat it back, that moraine would remain, and you can be left with multiple ones depending on how many retreats there were. And that's the whole lab. So hopefully that's not too terrible. and please let me know if you have any questions.